This is Pam Smith with Farm Journal Magazine, and I'm with Joe Keaschell with Pioneer. And Joe, you guys made an announcement to us today about a drought tolerance trait that's coming down the road. Can you tell our readers about it a little bit and what they can expect to see?
Sure. We're excited about our new drought technology, and we have both a Drought 1 and a Drought 2 generation of drought tolerance. The Drought 1 is based on native genes that are in corn today. They're not subject to regulatory approval because they actually are native genes in corn. The secret of Drought 1 is to understand where these native genes reside on the chromosomes and then to track those through the breeding process so that we can assure that those favorable sequences at specific locations on chromosomes end up in our best native drought-tolerant products. And once we find that first gene, then we find that second gene and third gene from a native base, we can bring those together to get drought tolerance from our native germplasm base that's better than anything that's ever been experienced before. Our second Drought Tolerant 2 is based on transgenic drought traits, and ideally we'll add those to the genes that we identified in Drought 1 to have a cumulative superiority in drought tolerance. Those are regulated because they are genes that have been engineered for drought tolerance and are inserted via transformation, so those do take a little while. We're looking at mid-decade as far as release time for those. But we're excited. We think that Drought 1 and Drought 2 can complement each other well. We're looking for that 6% yield advantage with Drought 1 over the industry-leading drought-tolerant products that are on the market today. And we're excited about what's happening in this area.
You guys have been, I know you're a plant breeder, and you said that breeding for a drought tolerance is not an easy prospect, is it? And there's a lot of things that have to go into the mix here, but you guys have been looking at this for a long time. Why now?
Well, drought tolerance is a very complex trait. Yield itself is a complex trait, and drought tolerance is yield under stress. So it really is all the complexities of yield and then the stabilization of that yield under stress environments. And the things that are challenging are the fact that drought can happen anytime during the year. It can happen early, it can happen at tassel time, or it can happen during the grain fill time. And we really think there'll be different genes responsible for superior drought tolerance during those different stages of the plant's life. So it'll be a multi-genic trait to get to where we ultimately want to be for drought tolerance. And you also have the heat component. You know, we can do a lot of drought screening here in California at Woodland, but the nights are extremely pleasant here. It really cools down, and as we get to places in Kansas and Texas, a lot of times the nighttime temperatures are very high. So we need to account for that heat-tolerant component of drought tolerance, which can vary from different regions of the country. So we have to look at the heat, we got to look at the ability to really absorb the water that's in the ground, and also we want to bring the management practices along with the genetics so that we can preserve the moisture that's there, whether it be using strip till or no-till. But we need to make the best use of the water available, and we want to add the genetic component to allow that to happen.
And so why is it all kind of coming together? What's making this happen now as opposed to in the last 50 years that you've been looking at it?
Well, the science of genomic understanding is just exploding. We can create millions of marker fingerprints in a short period of time. And as we generate progeny, hundreds or thousands of different progeny from the cross of two parents, we can molecularly profile those progeny. We can grow them in the defined condition or the defined environment that we create. Look at the good ones, look at the bad ones, and then look at the molecular sequence similarity and dissimilarity across these thousands of genes, and all of a sudden we start seeing certain sequence that show up consistently for those that are superior for the trait that we're looking at. In this case, it's drought tolerance. And then once we find those, then we can validate those over the year and combine the multiple traits that we find that give us the right direction for that trait we're looking at.
All right, thank you very much.
Thank you.